Today, our presenter is Christopher Wolfram, technical lead from the R&D Special Projects team. Christopher will be talking to us about building a human and AI workflow. Christopher is also the developer of the OpenAI Link Packlet, and he will also talk to you about that and some other interesting things. So without further delay, we'd like to get started.
All right, so let's see here. Right, so I think that the title of this section is about building a human AI workflow. And I think the idea here is both ways that you can kind of modify the behavior of ChatGPT or the LLM more generally by prompting it. And then also we'll see later stuff about developing your own plugins that can, that can modify the behavior even more. And many of which can work with the Wolfram plugin that comes with ChatGPT. So let's see here. So the first thing I want to maybe show is how you can kind of prompt ChatGPT to sort of modify its behavior throughout a conversation. So you may have seen some, I think Jason had some examples in his session that were a little bit like this. But the idea here is that you can give it sort of instructions at the top of the conversation that it will sort of modify its behavior for the entire chat. So here's an example prompt that I made before that basically just tells it that it should always use the Wolfram plugin to get an image that it will use to sort of make its response more interesting in some way. And it just really nails home that this is what it wants you to do, and it's trying to be very clear. So if I send that, it will probably just tell me that it understands. Right. So now let's do an example. So if I try and tell it something like write a paragraph about koalas, right? So hopefully this should come back including an image of a koala, because it's pretty obvious what what image we want here. Let's see. Yeah, hopefully it doesn't write too much about koalas, as interesting as koalas are. Right, so now it's going to make a query for koala image. You see it got back, a link, and now it's going to hopefully insert that image. And there it is, and there's our beautiful koala image included in our response. Maybe another one, I could try something like, tell me about, I don't know, New York or something. Just to show that this will sort of apply throughout the conversation. I hope it doesn't write too much, actually. Let's see. Well, we'll let it write a little bit, and then I'll maybe tell it to write something shorter if it takes too long. Okay, perfect. Let's see if it makes a good query here. New York image. I'm not sure actually what Wolfram Alpha would do for New York image, but hopefully it'll have something. Okay, it interpreted as New York State. Oh well, that's fine. I did tell it to tell me about New York. Oh, and it was telling me about the state. So okay, perfect. Then there's a good New York State image. So right, so this is a pretty right. These are pretty simple examples, and this prompt is kind of marginally interesting, but it doesn't modify its behavior that dramatically. So it may be, you could imagine though there are certain contexts in which you might want to have a prompt like this, so that you can have for example, you could have a chat where you pre-prompted it to say, oh, always respond, with chemistry facts or with math facts or something like that, and you can have it kind of act as though it were a math teacher or something, and then this kind of pre-prompting can be quite useful. So another example though, which I think maybe changes its behavior a bit more dramatically, is let's see, it is basically that you can get it to use the plugin to do sort of software debugging. So, for example, here's a prompt that I also wrote previously. So, essentially, what this says, it just lays out kind of a relatively straightforward kind of software development workflow. So it basically asks it to make up, I'll give it a task, like to write some Wolfram language function, um, and then it will and then it will it'll write some test cases, and then it will write a definition for the function. And then because it has access to the Wolfram plugin, which can actually run Wolfram language code, it can then test itself. So it can test the code on its own, check if it worked, see if there were any errors, and if there were, it can try and debug them. So it can go through the whole kind of software development cycle that humans go through, but that ChatGPT on its own without a plugin can't really go through. Um, right. So we'll let this run here. Right. Okay. So it says it understands. Okay. So let's try an example. So I have an example of write a function for testing whether a string contains a US phone number. And let's see how it does here. So, ChatGPT is, always different every time, but often it, right, okay, oh, so it's going straight in with, okay, this is interesting. This is doing different behavior from what it's done in the past, as it would do. So it's defined a version of the function, and then it's running its test cases right in here. Um, oh, did it get it? Wait, let me see. Okay, sorry, this is a bit, it's written it all in this very kind of incomprehensible way. So it wrote a regex that is pretty incomprehensible, especially because it's in an escaped string in here. Right, but this is basically the function. And then let's see, it ran these test cases. And you always have to check above to make sure that it's telling the truth. Yeah, true, 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 false, false. Wow, okay. So it did it first try there. Okay, so usually it doesn't do it first try and it has to go back and forth and go through this whole development flow that was sort of laid out up here. But that's impressive that it just did it itself. It's also nice to see though that it could test it and verify that it does in fact work. I'm gonna do something hard though. We're gonna try this again. I'm gonna give it a different task. We'll try a new one. The Wolfram plugin enabled. Fingers crossed. Perfect. Okay. So now let's try, I don't know, what's a harder one? We could try saying, write a function um, for, I don't know, testing whether a string is a valid US street address. So I don't know, vaguely similar kind of string processing thing, but different task. Okay, now it's too clever for its own good because now it knows how to use interpreter. So interpreter is a built-in function which I think there's an interpreter type for street address, although I think it might return a geoposition. Um, but let's see. Oh, interesting. This is how it's checking whether it's a US. It could have used restricted maybe, but instead it's using this tested to make sure it's a US phone number, or sorry, street address. Okay, let's see if it works. Okay, so in this case, the function didn't work, but let's see if it can debug it. It's written this in a pretty convoluted way, so I'm not sure if it can figure this out. Oh, actually, no, this did something brilliant. So you see, it wrote a new function. This is actually something that I found it often struggles with. Is when it's debugging a function, it'll just try and rewrite it till it works, but often it needs to break it apart. So here you can see it's actually broken apart and it's made a simpler function so that it can inspect the outputs. Um, oh, okay, this is interesting. So basically, for certain types of return values, uh, the Wolfram plugin will return a URL to an image, right? So obviously, if you want to return a plot, it will return a URL linking to an image of that plot as opposed to text. So I'm guessing this returns some kind of, it returned a geo position, but I wonder why the geo position is being returned as an image and not as a geo position. But okay, I'll let this try for a little bit longer, and I'll probably stop it. Um, but you already get to see though the sort of flow here where it's in this loop where it's sort of, we've just given it a task and now it's just going off and talking to this plugin and having a whole back and forth without having to you know with very little involvement from me, which is quite nice. And you can imagine how this could do all kinds of more sophisticated programming tasks than if you just sort of gave it a task and asked it to write code just from nothing. So right, so let's see. I'll let it try one more time. Although I don't think this the way it's written this, I don't think it's going to get any closer. Um, so I should probably stop it around now. Yeah, because I want to have time to show how to make your own plugins. So okay, I'm going to stop this here. But we get a sense of how the back and forth goes. Actually, I can show you. I'll share really quickly because I'm going to need to share my notebook anyway. Okay, so you should be able to see this notebook on the left here. There we go. So in this notebook, I know it might be a little small, but this is a chat that I had with it previously and that I backed up in case ChatGPT wasn't working today. But you can see in this one, I asked it to make a phone number or make this phone number identifying function. And you see it did this whole back and forth. So it wrote it one way, then it didn't work, then it tried another way and another way, until eventually I told it maybe try using string patterns instead of regular expression. And then it tried a few more times until eventually it says that it worked. And then you get a report of how it responded to the tests and so on. So right, so you can see that this is sort of similar to the cycle it did over here, although in this case it was a slightly easier task, and so it sorted itself out. But right. So now I want to just show quickly here, and maybe actually I should make the font a bit bigger. So there's a Packlet that we released relatively recently, maybe a week and a half ago or so, called ChatGPTPluginKit. So let me see. I can actually I'll post a link to that in the chat. I'll also post a link to the source repository. So essentially, this is a Packlet that lets you deploy your own ChatGPT plugins pretty easily. So in like a line or so of code. So let's try it. So here I've loaded the Packlet. This is how you load Packlets in Wolfram Language. And now let's try making a plugin. So I think I just say ChatGPT plugin, and I give it an association. And let's give it a name. So there's a little demo that I like to do, which is like the city population finder. So this is just going to be a simple plugin that you give it the name of city, and it gives back the population of that city. And this plugin has some endpoints. We'll call this one get city pop, and then we'll give it an API function that'll be the actual code that will be executed when this is triggered. And I'll just write something like it takes a city of interpreter type city, and in the body we'll just get the population of that city. If you want to know more about this syntax, you should look up API function, which was sort of which you can use for other kind of cloud functionality, and which looks like this. So if I run this, this just sort of represents this static plugin object. But now if I say ChatGPT plugin deploy, and maybe I'll save this in a variable, I get back this ChatGPT plugin deployment object. And then it gives me this link here. If I click this, it'll copy it. And now if I go into a new session or new chat, and I go to the plugin store, develop your own plugin, and paste this in, I should be able to say find manifest, and you see it found this city population finder function. And now if I say something, and I'll actually disable the Wolfram plugin for a moment while I do this, so we know that it's not cheating. I can say something like, what is the population of Chicago? And hopefully it will call the city population finder plugin. You can see there it is, calling city population finder. It put in Chicago and it got back this string giving a number of people. And then you see that ChatGPT is accurately returning that number of people, although it's inaccurately also acting as though this depends on its knowledge cutoff, which it doesn't, because this doesn't come from ChatGPT's training. But so it goes. So that's a pretty simple plugin. Let me see. I'll close that one down for a moment. Here's a maybe more sophisticated one. So essentially, this code here is actually all that you need to actually, it's even more than you need to train, to basically create a vector database in Wolfram Language for searching Wolfram Language documentation. So essentially all this does is I use basically Wolfram Language's own knowledge of its own documentation. So there's programmatic ways of getting access to the documentation. And I'm using that and I'm feeding it into GPT-3 to generate embeddings for different documentation pages, and then creating this nearest function for searching them. So now if I want to query it, I can just take that nearest function and give it the embedding of some query string. So something like, generate an RSA key, and then maybe I'll say, give me the 10 nearest matches. And you can see then these are the functions that it thinks might be relevant based on this sort of semantic search. And it's right, generate asymmetric key pair is the most relevant function for generating an RSA key. Right. So let's try here. So here I have got another plugin that's sort of written locally. And all it does is it essentially, there's some prompt information and so on, but all it does is really just use this search mechanism that I just made right here. And it provides an endpoint for that. And then it also provides an endpoint that lets, given the name of a symbol, it'll let ChatGPT read all the docs for that symbol. So if I deploy that here, I'll take that link there, and then now I will add that plugin I'll install that plugin in ChatGPT, and I'll also enable the Wolfram plugin. And now let's try something a little fancy. So I'll try something like, I don't know, we'll try generate an RSA key and return the public and private keys in hex. So let's try that. And maybe I'll tell it also, I'll prompt it a little more. Look up any functions that you might need in the docs. So now it has access to both the Wolfram plugin and this documentation plugin. So you can see it starts, because the critical thing here is that the ChatGPT doesn't innately know about all Wolfram functions. It knows about a lot of them, but there are a lot that it doesn't really know too much about. But so with the ability to search documentation, it can do a lot more. So in this case, you see it searched the docs for generate, RSA key generation. It found out about generate asymmetric key pair. Then you can see it queried, let's read the docs for generate asymmetric key pair. It was giving back this whole string that basically is a bunch of documentation. And now it is running some code. So let's see. So it tried to call generate asymmetric key pair. Let's see. Okay, it misformed this looks pretty good, except that it misformed the method option, it got an error that basically this shouldn't be a list of rules, it should be an association, and then it fixed it, and then you can see, right, and then you can see that it actually got back the right output. So it got this association that includes the public and private key, or at least some parts of them in hex. So now, or in hexadecimal. Now it's copying them back to us. So it'll probably take it a bit of time because these are quite long. But I think this is pretty nice because you see that, right, if I close all these down, again, like with the example we saw before, it sort of went back and forth and had this whole flow where it was going between the documentation and the kernel and executing things, until eventually it got something that worked, and now it's dutifully writing out the results. So yeah, and it's worth mentioning also that, at least, again, you can never say things about what ChatGPT knows and doesn't know about, because it's always sort of in flux. But at least last time I tried, ChatGPT didn't really know about generate asymmetric key pair and didn't know how to call it correctly. So the fact that it could look up the docs here actually made it able to do something it couldn't otherwise do. So yeah, so I think that's about it for now. Maybe if there are any questions or anything, let's see. I'll look at if there are any outstanding Q&A questions. There's the first one from David is, how did ChatGPT know that your plugin would be useful in finding the city's population? What if you had labeled it simply Pop Finder? So that's a good question. The answer is, so we can actually look. Let's see, if I expand this out a little bit. If we go to the debug panel, oh wow, this is okay. I'm gonna have to decrease the magnification. Sorry for anyone who has a small screen, but you can see if you look on the debug panel, these are the raw messages that go to the model. And so if we look at these, you can see how the prompts actually got interpreted. So if I go to, let's see, this was the chat about population of Chicago. So if I go here, this was the raw string that was fed to the model at the beginning. So you can see this, essentially this thing from namespace to this thing here, that's the part that was, that's all that the model knows about this plugin. So you're right. So in this case, the only thing the model had to go off of was the fact that it's called city population finder, the function's called getCityPop, and it takes a city. If we'd called it something more cryptic, it would have no idea what this function does. So right, basically, in that case, the name was enough and the function was self-explanatory enough, it figured out what to do. In other cases, it can be more complicated though. So for example, if I go back to the documentation example here, we look at the debug. So this is all stuff, all this prompting is for the Wolfram plugin. Let's see. Right, here, this is the prompting for the documentation plugin. So you see, when I defined the plugin, actually, I specified a prompt, and I gave I gave some other prompt information on the different endpoints, and you can see all that got inserted over here. So this is the prompt that I put, and then here's the prompt on the different endpoints. So yeah, so essentially, often it can kind of guess whether, guess what a plugin does, and if it's self-explanatory, you don't need to prompt it very much. But anything more sophisticated, you need to really tell it what to do. Yeah, that's a good question. Let's see. So the next question is, how does ChatGPT decide to call a plugin or not? How does the decision engine work? So it's another good question. The answer is, it's just the model gets to decide. There's no right. It's essentially just up to the model and how it was fine-tuned to decide whether or not to call the plugin, and of course how you prompt it. So essentially, the way that it actually calls a plugin, and you can see that in this debug panel again, is it'll start is basically if it just writes out essentially that I want to call a plugin and here are the arguments, then the system that actually runs the model will stop. It will it'll evaluate the plugin on those arguments and then paste back the results, essentially. So it's just up to the plugin whether or not it ever wants to write out a string that basically says, I want to call this plugin. Right, yeah. Okay, question from Sid. How general is the ability of ChatGPT to search and deliver queries about the structure and content of the complete Wolfram language documentation? So this is an area of active experimentation. So essentially, I think ChatGPT, I think it got to read a lot of the documentation in its sort of base training, although it doesn't remember everything it's read. So if you ask ChatGPT questions about, for example, let's say I don't know about some kind of programming task. Like let's say I've never heard of the function partition. So partition is a function that splits. You could say a partition of a list, comma 3, and it will split the list into pieces of size 3. So if I let's say I didn't know what that function was called though. If I said something like, what Wolfram language function could I use to split a list into chunks of size 3, for example? Let's see. So often ChatGPT will innately, oh, actually, this is doing something interesting. Okay, I was going to say ChatGPT often innately knows and can tell you about functions it's heard of. In this case, it's done something quite interesting though, which is it's called the plugin to get a list, and then it's used the list to inform its decision making. And you see, it didn't just blindly pick the top result; it picked the second result, which is the right answer. Split is actually not very relevant for this task. So that did quite a good job. So yeah, we've been doing a lot of experiments with stuff like this, of things like semantic search for documentation, as well as having the model suggest relevant functions given, a plain text, I want to do X thing. What functions would be relevant? Yeah, you can see here it did a pretty good job. So yeah, that is a very interesting area. Let's see. So there was a question from apparently from Tuesday about does the Wolfram OpenAI link packlet and resource function allow you to track the number of tokens sent and the cost incurred from using the API? Basically, yes. So there's two ways to do it. I mean, one way, so essentially, if you call, if I go in here and I use OpenAI link, the OpenAI link packlet, which I set up earlier, and I say OpenAI text complete, hello there, and then it responds. So there's two ways you can check this. One is there's actually a response usage parameter, which tells you how many tokens did it use. And if you say something like all here, it'll return this completion object that includes both the text completion and the response usage. So that's one way. Another way is, of course, the OpenAI dashboard will tell you how many tokens you used. And I think, actually, I don't, is this set up? I think you can set the OpenAI user and the $OpenAI user. You can set this to a string. And then I think in the OpenAI dashboard, so like I could set this to, Wolfram Language or something. And then I think on the OpenAI dashboard, you can see how many tokens the Wolfram Language user has used compared to maybe other uses you have. So yes, there are some good ways to do that. Right, there's a question from James Linton about I'm creating my own plugin. Is it possible to use mine and Wolfram simultaneously? And if so, how does that work? For example, sharing libraries, etc. I'm not sure exactly what you mean by sharing libraries, but certainly, let's see. So certainly you can use multiple plugins at the same time. So like in the example we saw just a moment ago, I think it was this one, you can see that it was calling both the documentation plugin that I just deployed locally, and it was calling the official Wolfram plugin. So you can certainly have multiple plugins running at the same time. Yeah. And these plugins can do whatever you want. So like, for example, and maybe they can interact with each other too. So in this case, this plugin I have is actually running on my local computer. So for example, this plugin could do crazy things like, write files or set variables and stuff like that. And I could have another plugin that accesses those same files and variables. So they could interact in principle. But yeah. Let's see, maybe just a couple more questions here. Let's see. Right, so there was I guess a question or idea from Christian about including the Wolfram language documentation in the OpenAI model. So I think I'm not sure that there's, I mean, right. So presumably OpenAI can do things like read our docs in their training, so that sort of ChatGPT has sort of innate knowledge of the docs in the same way that it maybe has innate knowledge of, like, if you ask it to tell you about Hamlet, it's probably read Hamlet and it can tell you, these are what it remembers what everyone said and stuff like that. So presumably they can include it in training in a similar way to how they include things like that in their training. But right. Otherwise, though, I think that plugins really aren't a bad way of doing it, because it's sort of the problem is just that it's a much lighter weight way of giving it access to things it might not otherwise have access to. And of course, if you wrote your own functions, it's also interesting because, right, suppose you wrote your own functions or functions that are in some new packlet that was created since it was trained, then the only way it could possibly know about those functions is through some sort of plugin mechanism or something like it. Yeah, but I think yes, I think the more it innately knows about how to program, the better. Let's see. Okay, another good question from David. So if you write a plugin, you must essentially host it on a web server and tell ChatGPT the URL it can use to send text to the plugin and expect it to get a reply, right? So yes, that is basically right. So essentially the way these plugins work is you give it the link to a web server, in this case, localhost, so it's running on my local computer, and then it will talk to that web server and send an API request for any questions basically that ChatGPT has. So you can actually if you look at this ChatGPTPluginKit packlet, which I posted in the chat earlier, it actually has two mechanisms for doing this. So one of them is this thing, ChatGPT plugin deploy, which creates a local web server, so running kind of on your local computer, and in the kernel from which you deployed it. Right, and you can paste this into ChatGPT, and ChatGPT has basically a special case. If you tell it that the plugin is running on localhost, it will make the request to the plugin from your browser as opposed to from their servers. So you don't need to have special router settings or firewall problems or anything like that. If you say localhost, it'll just it pretty much works. As of yesterday, I believe, so if you've been using this, you may need to update your packlet. There's now also a ChatGPT plugin cloud deploy, which will actually deploy a version of the plugin to the Wolfram cloud. So I can try that. Let's try that with a simpler example here. So here we had our simpler plugin, and here before I had it deployed to localhost, but now I'm going to say cloud deploy instead. Oh, I have to run cloud connect here. And now if I run this, you see it actually gives me back this .wolframcloud.com URL. And now let's try pasting that into ChatGPT. So I'll develop my own plugin, give it that URL, and you can see it found it. And now I can ask it. I have to go through a lot more dialogues, but now I can say something like, what is the population of London? And now this should go to the Wolfram cloud and be publicly visible. So in fact, if you put this URL into your ChatGPT, yeah, there it is. It should work. right. I mean, contingent on the whole, developing your own plugin mechanism, which has its own various restrictions. But yeah, so through this mechanism, you can actually, I mean, first of all, you can deploy kind of publicly visible plugins that you can share with other people, which is quite nice. And of course, it also, it won't be tied to your local computer or anything like that, so it's a bit more robust. Yeah, yeah. Um, let's see. I think maybe one last question. So there's another question about is it learning from description in your plugin's code? So if you mean right, so I think here there's this section called description. I think that's right. Yeah, this description it doesn't learn from. So this description is essentially the human facing description of the oh, whoops, I shouldn't have done a cloud deploy of that. Okay, well, it's fine. Right, so that this essentially gives the human facing description of what the plugin does. So if I install this new plugin here, the documentation finder, you see this here is the description. Instead, the prompt is the model facing description. So yeah. Well, I think that's probably about it for today. But thank you everyone for coming, and of course, it's yeah. If you have any, of course, if you try anything with the ChatGPT plugin kit or make any plugins with Wolfram Language or anything like that, I encourage you to post them to the Wolfram community, and I'll might hopefully get to see them and so on. But yeah.